Good morning, one and all present here. Today, we will be presenting our mini project topic, which is PLC based automatic drilling setup. It's presented by myself, Nischal Dinesh, and Prajwal and Sarthak Das, guided by Mr. Vinod Kumar S. Saw. The objective of our project is to build an automatic PLC drilling setup which runs using PLC and which is designed using Unity Pro software using SFC and ladder logic concepts, which results in a more efficient and industry-friendly drilling setup. And this not only gives higher precision of drills, but also reduces human error and human interference.
So let's talk about what exactly is a drilling machine. A drilling machine is a primary tool used for making round holes or driving fasteners. It is fitted with a bit, either a drill or a driver, depending upon the application, and it is secured by a chuck. Now, the size of the drill or driver varies based on the application which we need. Now, some power drills also include a hammer function. This drills vary in speed, power, and size as mentioned earlier. Now, for this particular project, to make this drill machine, we are using SFC. A setup is designed using sensors where the conditions are met. Now the drill starts to extend and read the piece and drill. Once completed, it returns and checks if the user is satisfied with it or not. If the hole is proper, we come out of the loop. If not, we repeat the process till we meet with the actual accuracy and precision of the drill. Now let's talk about SFC, sequential flowchart. A sequential flowchart is a graphical programming language used for programmable logic controllers or PLC. Now preparations of functions and charts for two control systems. Now let's talk about the components. Now first component is transitions, which is associated with the help of logic conditions, where we use the ladder diagram. The next is direct links between steps and transitions. Now steps in SFC diagram can be active or inactive. Actions are only executed for active steps. For inactive steps, it's disabled. A step can be active for two motives. One is the initial step as specified by the programmer, irrespective of any reason it is going to work. Second, it was activated during the scan cycle and not deactivated since. Now, when all the steps above it, when all the steps above it are executed, the above parts get deactivated, while all the steps below it gets activated. Nikhil, you can go to the next page.
Moving on to the ladder diagram. Ladder diagram is widely used to record logic structure for industrial control. It is used to represent control circuit and it is further used to record the logic structure for industrial purpose. As control circuit become more complex, ladder diagram can be less complex and easy to understand and read. Ladder logic has evolved into a programming language that represent a programming by a geographical diagram based on the circuit diagrams of relay logic hardware. Ladder logic is used to develop software for programming logic control, used in industrial control applications. The name is based on the observation. The programming in the language resemble ladders with two vertical rises and a series of horizontal rungs between them. Moving on to the PLC, it is an industrial control computer system that monitors the state of input device and make decision based on the custom program of the control state. The popular programming languages is ladder diagram, free product diagram, and SFC. The most commonly used is ladder diagram.
Now let's talk about some of the research papers which we followed while making this project. The first paper is Design STM for Curvature Drilling Machine by using PLC automation. Now in this proposed system, sets the production count and drilling angle is fixed to the drill workpiece. Then we turn on the relay and the induction motor, and we are using the induction motor and hydraulic power pack induction motor for the drilling application. Now the outcome which they got here was the project can be concluded to be innovative, and there is a lot of scope for improvements. Now using this, we can make a drilling machine which is better, more efficient. Now let's talk about the second paper, which is a PLC based automatic cutting machine. Now here PLC acts as a main controller or the brain of the project. which will accept all the inputs from the proximity sensor, and then accordingly it will take the control action to the conveyor and do the necessary cutting process. And the outcome which we got is the for cutting machine based on programmable logic, controller based machine has got faster execution, more efficiency, more precision, and there is less chances for rejection. The third topic is automated drilling machine based on PLC. Now here the cycle process is start when the switch is pressed. Now once the switch is pressed, the linear motor is put accordingly and the drilling machine goes to the home position and rotate the disc and brings the desired result. Now the outcome which they got is the prototype is done to drill a small hole in the wooden piece which is about 8 to 9 millimeter in depth, and they perform 3 drilling objects per minute, which can be improved. And further, this increases the efficiency of small drilling machine instead of human work.
Moving on to the methodology which we have used in our project. So here is a flow chart which we have followed for our basic design of our PLC drilling automatic machine. Initially, we have our PLC drill. Now this is designed using SFC and ladder logic as we have mentioned in the previous slides. This data which is designed using SFC and ladder is transferred to the PLC. Once transferred, the data from the sensors which have used as mentioned in the previous topics are sensors like position sensors and etc. From the data from these sensors, it moves on to drilling operation. When each condition of the sensor is satisfied, it moves on to drilling operation. Once the drilling is completed, it returns the data. This return data checks or gives us as a user a feedback whether we want to continue or repeat the process or end the process. So if we have to end the process, it moves on to result. The result is a drill which completes drilling the piece. Else it moves back to the drilling operation till the user is satisfied. And once this is complete, it goes back to the result and completes the operation.
Now let's talk about this in detail. In this project, we have used various procedures and methods to get our final output. Some of these are, we have created an SFC in the Unity Pro software based on the type of application and outcome which we require. Then to design that, we've constructed a flowchart accordingly. Now, once we create the SFC chart for every transition step, we have made a ladder logic to satisfy the condition. Now, after we make the entire project and we execute the program and run and check for errors and warnings, we transfer the data to the PLC. Now, the application is executed step by step, and this operation can be done manually with the help of PC.
Now moving on to the components. The components we have used here is position sensor, push button, PLC, jumper wires, indicators, motors, USB adapters. Position sensor, it is used for the measurement of mechanical position. A position sensor indicate absolute position in terms of linear travel as well as rotational angle. Push button is used to push, operate an electrical device. Programmable logic control used to control different electromechanical process used in automation environment. The PLC takes input, performs logic on the input in the CPU, and then transfer on or off output based on the logic. Moving on to the jumper wires, it is a short wire used to close the circuit temporarily. Indicators issued to show changes in the programming making towards achieving a specific outcome based on the push button. Motor that converts electrical energy into mechanical energy. Now moving on to the USB adapters is a connecting wire which is used to transfer data, SFC ladder logic, PLC to Unity Pro from PC to software. Moving on to the software, we are used here is Unity Pro. Apart from this, we can use PLC softwares which can be developed in things. Flowchart. Initially, input is at I point. If the condition is PP, in the sense P is in place, or HP, that is high position, then it goes to the operation of drilling. Once it drills, If the operation is satisfied, we come out of the loop and the project is ended. If not, it goes to the intermediate position and again goes for drilling until we reach the satisfaction conditions.
Okay, let's talk about the arrow diagram. As you can see, we have here taken three separate positions, that is the high position, intermediate position, which is the IP, and the low position, which is LP. And PP is the place of the particle where the particle to be executed is going to be kept. Now, when we start the SFC, it goes to the low position and execute the drill. Now, once it it goes to low position and execute the drill. Now, if the condition is satisfied, the drilling machine goes to the high position again, or else it goes to the intermediate position and then again comes to drill unless the condition is satisfied. The arrow marks on the right, you can see we have used the timer. So check for how many seconds the drilling machine is going to operate.
Now moving on to the SFC diagram. So we'll see here. So these S0, S1, S2, S3, and all the further steps are going to be considered as steps, whereas the ones in between are going to be transition steps, where it is the link between S0 and S1. So here S0 is the initial step where the PLC drilling machine starts. S0 underscore S1 is a step where three condition has to be satisfied, which only then will move to S1. LP is our low position. T on underscore 0 is the output from our timer 1. IP is our intermediate position. LP is again a low position. And again, moving on, here we have a split. This split gives us the option to check whether it moves to the third position, back to the third position, step 3, or continue to the sixth step. Why is this? Because as we mentioned in the previous slides, that we are checking for 2 cycles. So this process repeats twice, and two times it drills, and the cycle repeats again another round where it totally adds up to 4 drilling cycles. So once these four drilling cycles are done, it moves on to the 6th step, where it comes out of the loop and moves on to the S5 underscore S6 transition step and moves on to 6th step. And in the 6th step, it starts to retract and go to high position. And once the piece has been removed from the place, it returns back to initial step for the next cycle to begin.
Let's see the ladder diagrams which we have used here. Now the first diagram, which you can see where the cursor is pointed now, is between the transition step of S0 and S1. So it will go, the SFC will go to S1 only if PB, HP, and PP, all the three are high. Now below that are the 2 compare cycles. That is as Nishal mentioned earlier. When we go to the 6th step, 5th step, we have a choice. If the circuit is complete, if we are satisfied, we go to the 6th place. If not, we go back again. Now the top timer is for the compare cycle 1, that is to go back to the steps to the intermediate position, while the below is where we satisfy, yes, the condition has been reached. Now below you can see S4 and S6. S6.x is the operate cycle where we are operating the drilling machine, and once the condition is done, we go back to the initial position. Next, on the right side, you can see there are 2 timers, timer 0 and timer 1, which is connected to S2.x and S5.x. Now this both S2.x and S5.x are used for the drilling machine application. First, S5.x is used when we come to the position for the low position for the very first time. And the second one, timer, is used when we go again from the intermediate position to the low position to check whether we are satisfied the condition or not. Now, this drilling diagram, okay, this ladder diagram is based on, we can see there are 5 steps, S1, S2, S3, S4, S5 is all for the drilling machine on. Initially, when we execute this step, S1 will be on, later on S2, then S3, then S4, then S5. And you can see the connection is similar to the OR logic. So it doesn't necessarily have to be all steps to be on only for the drill to be operate. Next, you can see cycle extension, that is the S1.x and S4.x. Now that is based on whether we are satisfied with the drilling operation or not. At the last, you can see the cycle retardation. Now that position comes when after drilling the particle or the piece, we go back to the intermediate position to check whether we have done it or not.
Now let's start the simulation. So here we see, initially we are connecting our SFC diagram from Unity Pro to the PLC. And now we're transferring the project to the PLC. Once all the data is transferred to the PLC, we can operate this using two operations. One is using the PLC itself automatically, or using the simulation mode, which is through the PC. So now we see here it's in the initial step. And now we are going to the transition step, which is the first transition step, which is S0_S1, where the push button has to be pressed. And then it should be in high position. And the piece should be in place. When these three conditions are satisfied, the condition is met and S0_S1 is transferred and is moved to step 1. Now in step 1, we'll see in the actions that in step 1, which we'll see that in actions, it's going to extend while the drilling machine is on. So here we see the drilling machine is on and the cycle is extending. Once it reaches the low position, it moves on to step 2, where in step 2, the timer starts, timer 1, where we're seeing here, it's wait for 15 seconds. The drilling operation takes over 15 seconds. Once 15 seconds is completed, it moves on to step 3. Step 3 is where it starts retracting. We'll see here that step 3, the drilling machine is still on, but here it is retracting. Now, as we see, once it reaches the intermediate position, once it starts retracting and reaches intermediate position, it moves on to step 4, where in step 4, it again starts extending to the piece and the drilling operation takes place once again. And this time, once it reaches the low position, it is going to drill for 7 seconds. We'll see here that once low position is met, the timer starts for 7 seconds. As you see, the loop is completed here. And after 7 seconds, the process repeats. As we had mentioned that now the cycle count is going to be 2. In the previous step, it was 1, cycle number 1. Now cycle number 2, so it's going to go back and repeat to S3, where the drilling is going to be on and cycle is retracting. Once it reaches intermediate position, it moves on to S4, where it is going to retract, extend, and the drilling machine is going to be on. Once it reaches the lowest position and drills again, as we had mentioned in the previous step, that it's going to drill for 7 seconds. Once the 7 seconds is completed, as you see here, 7 seconds is completed. Now it comes out of the loop. See, it comes out of the loop. And once it comes out of the loop, now it starts retracting. In this retracting state, what happens is that now it's not going to stop or check for intermediate position. As we have completed 2 cycles, it goes all the way up to high position. Once it reaches the high position, now we see that the drilling is switched off because all the conditions are met. Now the only thing which is happening is S6.x, which is retracting. Once it reaches high position, all the steps are stopped. The drilling is not on, the cycle extending is not on, nor is the cycle retracting. Once the piece, as you see here, nothing is on here. Once the piece is removed from its place, which is why we're calling it not PP, as in not piece in place. Once the piece is not in place, it moves back to the initial step and gets ready for the next operation to take place. Now, what was our outcome or output of our automatic drilling machine? Now, we saw that once the piece is inserted in its place, the drilling operation takes place. As and when the sensors checks if its condition is satisfied, the drilling takes place. Now, this happens twice initially. And once the drilling operation takes twice, the cycle is repeated again twice, which means totally we have 4 times drilling happening. Now, what this gives is higher precision and higher accuracy of drilling. And this also reduces human error or any human intervention. So by reducing human error, what happens? As you already mentioned, higher accuracy. So this happening multiple times and continuously, it gives us more accuracy, which gives us a better piece, which can be used for better purposes.
Moving on to the applications, it is mainly used for the accuracy because in a glass cutting which requires high precision, automatic drilling machine can be used. It is used as well as automobile industries, construction sites, and it is used in mining sector, PCB design. Mainly, changing of drill bit allows more extended use of drilling of different shapes and size.
So our project was successfully designed and implemented based on PLC control system. Now using SFC. Now this has various drilling applications which not only will reduce human work but also will increase the efficiency and precision. And this also eliminates the option of human error.
Thank you.
Thank you, everyone.
Thank you.